This talk is based on my work post where I describe how to implement backpack interface for containers. And the talk is beginner friendly. You only need to know about simple functions, data types, type classes. You don't need to know advanced features like type families or other stuff. But there are a couple advanced moments. So if you have any questions, don't hesitate to interrupt me at any moment and ask. I will try to clarify. So a couple words about me. Currently, I'm working at the Haskell company as a Haskell backend developer. And before, I was working at Soroka company for 2 years, and I was teaching Haskell at the University. And in my time, I'm working on my open source project in Kovanikov organization. And also there, I'm mentoring people and helping them to learn Haskell, because we always need more people in Haskell, right? So, what is Backpack? Backpack is a mixin package system. Mixin package system allows you to have mixin libraries. And the mixin library is a library where you can have your functions with types and your data types, but without implementation. You have only types. And the implementation can be deferred to some later moment. But you can still use those functions and you can type check your libraries against those types. And it's really useful. And you can see that there is no mention of Haskell or GHC compiler in the definition, and there is reason for this, because Backpack was proposed in PhD thesis of Edward Young, and the system is abstract. Basically, you can implement it for any language like C++ or Java. If you want to have mixing libraries, the thesis describes how to do this. It's not something specific to Haskell. But Backpack is implementing Haskell as an example, so you can have it. But for Haskell developers, it means that we have new fields in Cabal files. So we have fields like signatures, explicit models, and mixins. You probably never used them before. Not all of them are specific to Backpack. Some of them you can use without Backpack. You don't need Backpack, but Backpack uses those fields. And there is also a new extension for Haskell files. Currently, we have only .hs extension for ordinary Haskell models, and we have .lhs for literate Haskell files. But Backpack brings files with extension .hc for signature files. And also new compiler errors, because this is a very important skill for Haskell developer to understand the output of compiler error. And if you never work with Backpack, you will see new errors, and you will spend more time to understand what's going on. Sometimes it's not easy to understand. Currently, Backpack supports only by Cabal install tool. This can partially explain why it's not so popular in Haskell world. Now, there is open issue for stack, and there is PR pull request where the work is started, but it's not finished yet. So, in this talk, I will describe how to implement the Backpack interface for containers. We had a poll recently where we asked people what do they think about such interface. It looks like the majority of the people like the idea of this interface, and according to the comments, Backpack looks like the most suitable solution for this problem. But before we can proceed with the implementation, let's first understand why we might need interface for containers. Sometimes it's good to not have abstract interface because, well, if you use a specific container data type like map or hash map, you explicitly specify what performance and memory characteristics you guarantee. But if you have like general implementation, general interface, you can guarantee these characteristics. Though, according to my experience, for most map-like data types, it's not really important. There are a lot of cases where you don't really care what to use, map or hash map. You just use what's easier in your case, and not introduce new dependencies or something like that. And there are cases where you actually need this interface. That's why we need the general interface for containers. First example is to have polymorphic functions like this. Let's consider this group by function. It takes some foldable of elements. It takes some mapping function from elements to keys, and it returns you a map where the elements with the same key are grouped into the list. I wanted for this function so many times, but it's not in any library. So if I need this for map, I need to write implementation. But if I need this for hash map, I need to copy paste implementation. So because implementation stays the same, only type changes, but still need to copy paste. Or if I want this for int map, again I just copy paste implementation and change the type. So it's not really convenient. This is only one example, but there are other functions. Another motivating example is benchmarks. So sometimes you would like to benchmark different containers implementations. And it's interesting to compare map and hash map. Or if you came up with new algorithm, it's might be useful to compare with existing solutions. But if you want to write benchmarks, you need to write them from scratch by yourself, and you need to write this whole code. And moreover, for every data type, you need to copy paste the algorithm of the benchmark, the implementation. It's not really convenient. It would be so nice if you could have one benchmark suite where you can just plug in your implementation and compare it with other data structures very easily. It will be very useful. And another example is the same holds for tests. So functions in containers usually have a lot of functions like size, lookup, member, insert with key, folder with key, traverse with key, delete, a lot of functions. And of course, as a good package maintainer, you would like to write tests for these functions, but the more functions you have, the more tests you need to write. And a lot of types, they have the functions and they're very similar in their interface. So it will be really good if we can have one single glorified test suite where you can just plug in your implementation and test your containers against some test suites. Very easy. Yeah. Yes.
But doesn't point 3 kind of cancel out point 1? Because if you can make tests which will apply to, let's say, map and hash map, that means that there's some semantic connection between these data structures, which to me suggests that you could abstract that into the type class and then use that in number 1 to implement your group line via that type class.
You can write that class for general interface, and it's possible, and I will give 2 solutions, but that class is not the best solution for the container interface problem. So it's possible, and I guess the reason for not having such interface, for not having one suite, is because solution with that class is not so good. So yeah, it's possible, but Webpack provides to give another solution to the interface for containers. It's just a different solution. The problem is the same. So yeah, if we can write polymorphic functions for containers, we can write polymorphic benchmarks, polymorphic properties. It's not for some useful functions we can reuse for some real-life use cases. But there are some challenges in implementing interface for map-like data structures. First challenge is that the data types are different. It's not like we have only one data type and different implementation of functions. The data types itself are different. Also, every library has its own constraint from keys. Map requires OR constraints. The keys should be comparable, where the hash map requires keep and hashable constraints. So for keys, we can just abstract. Only for data type, we also need some abstraction over the constraint for keys. Another problem is that types for containers are actually different kinds. So map has 2 type variables, where the int map is a map where the keys are integer, has only 1 type variable. It doesn't need type variables, they have different kinds, and this introduces some difficulty in unifying interfaces if the structure of the types are different. Another problem is that some maps don't have efficient modification operations like insert. For example, maps from primitive containers package. In this package, maps are implemented over the immutable arrays, so they have efficient lookup implementations like binary search over the array, but they don't have efficient insert operations. If you want to insert in the array, you need to use array. It's not that fast. So they don't have these functions, but still you might want to abstract over every map if you want only query operations. And another problem is that different libraries have different constraints for same functions. It's different from the ORT and even hashable case. What I'm talking about is that even like function like empty that creates empty map, in one library it has constraints, but in another library it doesn't have constraints. So yeah, this case. This means that our interface will somehow take this into consideration. Okay, let's first have a look at the type class based solution for the maps before we can proceed with the patterns. The problem of having a generalized interface for containers is not new. There exists already solutions, and one of the famous is one in monotraversable package. So in this package there is only a piece of solution. There are like 4 or 6 type classes for different purposes. This is a set container type class. It has type family, container key, which describes the type of the key of the container, and some query functions. So you might see that this type class already uses advanced features like type families and some I would say not really pleasant constraints. With type class you need to work with. Okay. Another solution in our package Relut, there are like these phrased type classes in 2 cases. In static map where you have only query operations, and the dynamic map where you have identification operations. The idea is that you have type families for keys and values. It's similar to the solution for monotraversable. You can have the general idea of how you can implement containers. But as I mentioned earlier, there are some problems with type class-based solutions. One of the problems is performance overhead. Unfortunately, type classes are not zero, because they are not free, and sometimes a compiler can be able to specialize and to rely on functions. So you will need to pay with performance. And this might be not really significant and important for that class, like accessing your database or acquiring like Amazon service, because like you're already talking to the real world. But when you work with pure functions, like maps, you don't want to have this overhead. It might be really significant, especially if you like want to have generalized benchmarks. You want to benchmark real implementations. You don't want to introduce some overhead because the compiler is not able to specialize.
But surely the benchmark is you would use specialized pragmatic specifically force the compiler to generate code for each instance.
Yeah, but if we don't have this problem, we don't need to write specialized. For example, if you are not experienced Haskell programming, you might not be even aware of the overhead. You need to use write more code and try to optimize to be sure that you have implementation. And it's not only for benchmarks. You try this for every function where it works. It's not really convenient. Another problem, even with all existing type classes, is that the idea of the type classes is that you want to write polymorphic code that works for every container, but the polymorphic code with the existing type classes is not the code you want to write, not the code you want to read. The types are not really approachable. They involve some density with type equalities, type families. It's not really useful. And it's not really readable. So it's some solution for the problem, but it's not satisfying. It has some drawbacks, which we would like to avoid. So let's now see how you can implement this interface with the backpack.
Before you do, just as someone who has tried writing type classes, the one thing I haven't heard you say is a reason against using type classes. They get very big and very long and very much of a pain to fill out if you want to be exhaustive at every single little function.
Yeah.
Just if you want to try and have a function that does every one, especially if you try and duplicate behavior between map and intermap, where there's a function in one but the other, and that kind of stuff.
These classes are very small because some functions are not really all the implementation is over. And it's not that easy to extend a class system for the users. Okay, so let's first write some interface for the maps. We will create the map.hzip file. This is a signature file. It starts with a signature keyword, unlike ordinary modules that start with the module. Here we write that we have data map with two type variables, and we have class key. The class key represents constraint for keys. Yeah. Also, we require that we want from our map data type to have instance show. Just in case you can write it, you require this instance. And you write functions. You write only types of these functions using the data types and constraints classes, but don't write implementations. So this is only a couple functions. Of course, for map like that type, there are lengths of 20 different functions you should put in this interface. But this, for example, we keep it small. This is a signature file that contains only the types without implementation. And the Cabal file for this package that contains the signature will look like this. So the most important part is that signatures field. Map is a signature, so you don't put it in the exposed modules field, you put under signatures field. Otherwise, it's the same. So you put all signatures in like one package, and you can implement functions that use only signatures. Yes.
So I have just a small question. So there are two details here that seem to be a bit over-specifying. Like it seems that the signature says that map is a data type, not just any star kinded type, and it says that the key is a class, not just any constraint kinded type.
It's not really important. You will see as the solutions, the data shouldn't be. It's not required to be like the data type. You can have any type. Of course, you have them type alias.
Okay.
Yes, it's not says it's like
So it's the
only-
syntax.
Yeah. It says the structure that the data class. Okay. So let's just write some polymorphic function that works over this interface. It can be in the same package as a signature file, or it can be in different package. So let's implement our work function. It doesn't contain implementation, but the key point here is that we import signature, our signature, as an ordinary module. If you want to use signature, you can use them from the Haskell source code module point of view. It's just an ordinary module. So you can import it without problems. And you can see that the type is the same for group by function as I. So the only difference is that for constraint replaced with a key constraint. So one of the backpack benefits is that it still gives you simple Haskell. You can write code with like simple ordinary Haskell types without type level tricks like type families. But it's actually a polymorphic interface. And the Cabal file for this package looks like this. So it's nothing. It's just ordinary package. There is nothing special. I put this module into different package to show example how you can use this. But it can be put in the same package. That's called the country package that contains all imaginable implementations of the interface map you can use. Okay. Now we have an interface, signature file, and we have some polymorphic implementation. But we can't actually run this group by function, and we can't see the result. The implementation of map data type and the functions from signature is deferred. So we can type check this package, and we can upload it to Edge and distribute it, and our users can use it to write their own polymorphic function based on this, but you can't actually run. You can look at this module as a module with a call. It's like it requires some implementation to be complete and run. And packages with such modules that are not complete are called indefinite packages in the Cabal. All the look at the small creates. It's like the package is a function that takes another package as an implementation of the interface. So let's write some interface. For example, we will take as first example, we'll take the simplest one, is a map from continuous package. So in order to implement signature, I need to export all things as in signature with the same names and the same types. So here I can tell that my method type is a map from data.map.strict model, and my key class is just port constraint. So here I use constraint alias to tell that the key is just port. And I can write empty function without the function is just aliases to the map from the same functions from map model. The types are the same. You know, here the types are like exactly the same. They're so the same. So you can even implementations implement a signature like this.
So if you just go back to the previous slide there.
Yeah.
So one argument against using in type classes is specifically because you've got data.map.lazy and data.map.strict, where they use the same underlying type but have different functions.
Yeah.
Now, obviously, if one uses a type class, you have to wrap one up into the new type, and then it's meant to do every single function. With Backpack, do you still have to do a new type, or can you go and have a lazy module and the same module that implement the same signature with the exact same type?
Well, here I just specified that the map type is the same as from map, and when I not specify functions in shorter way, I just can re-export them. So if I want to implement signature for map.lazy, I can just write the same module to replace strict with lazy.
Yeah, so there's no problem there of having the same type of two separate Backpack signature. What do you call it?
Yeah, definitely.
Yeah, okay. Whereas type classes obviously you can't.
So this works because the types of the functions and the name of the data type are the same. You can just re-export, and when we will match this implementation against signature, it will we will compare. And now let's look at the Cabal file. Here we exposed our map.org model, but the interesting part is that we also re-export our map.org model as under name map. So this model is available under two names. There is a reason for this. We will look why this is needed later. But the idea is that the users of our package, they can import either map module to have unqualified or specified explicitly as a name. So you can use re-exported models fields without backpack. You don't need backpack. For example, there is this package base no prelude that allows to write custom alternative preludes, allows to use them easily. And it depends only on base, and just uses the re-exported models from base. It specifies all models from base without querying. So it doesn't use the backpack, but it can be used as field. But it's used with backpack. So basically, write this back. And you might notice that we don't depend on our signature file, on our package use signature. Here we just depend on the containers. You are not forced to depend on the signature files because you can have different signature files, different packages, and so it's easier on the consumer side to choose the signature you want and then choose the implementation. Okay. And the last part. So once we have the interface and we have some polymorphic function and we have implementation of the interface, we can now use this interface and see the result. So here how the main function look. We just call our group by function from map.config model over the list of some elements. And the Cabal file looks very simple. We only tell that we depend on the containers for the script package, the package that implements the signature, and contribute the package that implements group by function. So the idea is that because we re-exported map.org module under map name, it will be merged with the signature. So if the signature has the same name as the module, it will be a substitute automatically.
So what happens if you happen to need two different packages that both implement the same signature? How do you choose which one you actually use?
This won't work, but I will cover later how to use different implementation. So if you want to change the implementation to some different package, for example, if you implement for hash map, you can just change this line, change the package, and it will work automatically. It's very easy to substitute the implementation just online in Cabal file. Okay, it doesn't really make much sense to have an interface if you have only one implementation. So let's also implement this for hash map. This is just a quick reminder how a map looks like. And it could look, for hash map, it could look like this. There's the only difference that they use a hash map, data type, and our key is just alias for pair of constants. We require from outside parameter to be equal and hashable. But unfortunately, this doesn't compile. As I warned you, there are new errors in Backpack. So type constructor has conflicting definition in the model and HC file. And there's something try at reducing the type synonym. So there is limitation. If you use this type synonyms, you should add reduce them. It's not possible to write like this. And there are no type level methods in Haskell currently, so we can't write like this. The workaround I came up with is to use is to write key plus like this. Instead of having type areas, we can write plus with constraints equal hashable key and implement it for every type variable. It has these constraints.
So back accepting you define it as a class rather than having to define a class and then type key equals class name.
That would also work.
I'm saying I'm just a bit surprised that it will pick up the class as well rather than looking just for a type specification.
Well, we used that alias for art previously and it worked, but the requirement restriction that is reduced.
It's the fact that it's generic and that it can pick up either a type alias or a class name.
Yeah, makes sense, right? It doesn't matter what it is, as long as it's behind this constraint.
Or starting constraint, yeah.
But that's what I'm trying to like, that's why we'll specify and take that block.
And also there are some extensions required. So
Do you really need one on local lines?
yeah, it says warning when I try to use it. Some
Okay, but you've got none of local line that need
maybe there's some way to work around this, or maybe it works only for the latest JSC. I'm not sure. Okay, so now we can have two implementation of our signature map and hash map. Sorry, I just want to say that about package. So this is in different package. We have ordered strict package for implementation of map, ordered strict, and we have map unordered strict package with this implementation. You don't want to have these dependencies for containers and not just containers in map package. But it looks like the same. We have map.hash model and we re-export it under map name. So now, what if we want to use both implementation in the single package? As it was pointed out, they have both the same name, available under the same name map. So if we just specify both dependencies in our compiler file, how compiler can figure out which one to use? And if you want, it will error you. So it's like, if I can choose, I will print error. But you can use mixins field in the compile, and here how it looks like. So in your depend, this is specify both packages with like map implementation and hash map and config. And mixins fields allows you to so here you say that okay, I want the module map.config.group from the containers config package, but I want this under the name map.config.group.ort, where I use map signature as a map ort. So and because map ort module comes from map and order strict, this will be from map order. Also you say that okay, now I want this module but under different name .hash, where I use map from containers unordered. So here you renaming the model and you make it available under different namespaces. And you also specify which signature implementation you use. So here basically, if you look at the package as a function from module to the implementation, here you're basically passing an argument with a function and this is specified. And you can also, so mixins allows you to not only use this backpack substitute signature implementation, they also allow you to just rename modules. So you can, this requires field and you can, I just want this module from this package but under different name. If you just don't specify this requires field, you can just simply rename module and use them. This might be useful if you don't have this re-exported fields in the map packages. Also like, if you just write only map, in every package you have only map module. But now you can have the same implementations with different names. But here you can just rename those modules and there you use renamed versions. So, but for users it's easier to have both implementation. As a package maintainer, you can raise it under two names and make it possible. So, and now main file looks like this. So we just use a group by function from different modules that is specified in the about file, and we just will use different implementations. In the first one, we will use the group by for map and the group by for hash map. So basically, like there are two modules, and there are physically two modules. It's like if you wrote the implementation of group by for different types manually, but Webpack copy-paste implementation for you. You might think that this only uses the different implementations of signatures. And you don't need to wait for substituting implementation of signature. You can have check group by function before this. So this might be useful. This is a simple third-party example. Okay, now this tricky data type int map that has a lot of problems and challenges. One problem is that it has different kind. We specified that we have only two type variables in our data type, but int map has only one type variable. So we can just write type map equals to int map. And the other problem is that we specify that we want some constraint from keys, but there is not actual constraint for int map for keys. The keys are just integer, so we don't actually have constraint. So the workaround for both of these problems is to write implementation feature like this. We implement map new type, which is a wrapper around int map, and we will use k phantom type variable. So it's not used in the implementation of the int map in the right scan of the type, just int type variable, just to have our kinds match for map that type. And we write that our key constraint is this magical part is a type equality partially applied to int data type. So constraint for our keys is that keys should be equal to int. So basically they should be the same as int. This tilde operator is a type equality in custom, and we can partially apply type level. So when you write our generalized function like this, it's the same type as in signature, but the key constraint is equals to int. So instead of writing int instead of k, we just write some constraint, and our map is new. So here we can just re-export all functions. We need to not only write all functions, but also do these new types. We need to unwrap from new types, unwrap from new types. Install the other new types don't introduce performance overhead, but it's possible even to implement these functions with squares functions to give strong guarantees that we don't have performance overhead. So, and even if this solution uses some advanced features, this is only implementation file. If you use signature, if you write functions, you don't need to care how it's implemented internally. You just only need to suffer once when you work with this. Okay. So, but unfortunately, this solution has some drawbacks. It's not perfect. There are some problems. So let's take a look at this function. Consider we added toList function to our signature. This function has this type. Map from keys and values to list of pairs of keys and values. And well, in reality, you don't need to have any constraint. Usually, this function just traverses your data structure and it just outputs. You don't need to have any constraints. But if you write this for int map, our implementation, it doesn't compile because here k is a phantom type variable, so you can actually convert it to you don't know that the key is equals to int, and if you just write here int, it won't match the signature. The signature you have this type. So unfortunately, we need to add a key constraint to our signature. And this is a problem where the implementation of one data type affects interface of all other data types. So we need to add this constraint to the toList function in signature and in all other functions. So it means that we can re-export.
Can you work around this by making the wrapper thing to be instead of in type, and then basically, as when Peter mentioned in the implementation, you will know that it has to be in, because that's the only constructor you have.
You mean for new type constructor?
So instead of making I am a new type, you make the GADC and have a constructor only for the case where the index is in. And then in the implementation of toList for int map, it's just by pattern matching on the wrapper, you would elaborate the right hand side type to have in the
I didn't try this solution. It's worth trying. Maybe it will work. but I might assume that GADT won't be new type, so it probably will be some performance overhead. So it won't be just new type record. So it's like trade-off, either if it works, either we add constraint or either we don't add constraint. But I think this, well, personally I can live with this trade-off. I never used to list function where I don't have constraint on the types. We just think you're working with specific data types. So this is something that I can live with. But the good part about Webpack is to not have performance overhead. So it's just basically replacing code for you. And if you need to try very hard to not introduce this overhead in your implementation. So trying to catch what we can do. Okay. Another problem, as I mentioned earlier, is read-only containers. So there is this primitive container package that don't have insert operation. So this means that we can have one signature with all functions, like from lookup to insert and delete. Because when you use the signature, the algorithm that checks that your implementation makes signature, it checks that you have implementation of all functions from signature. It doesn't allow you to implement only all part of the function. So this means that we need to split our signatures in at least two parts. So this is what I did, but before I came to the proper solution, I tried the wrong one, and I want to tell you what doesn't work. So what doesn't work if you have a signature called raw map for read-only map, and where you have data type and key and all query operations. And if you try to write signature map that just imports raw map and uses the same types as key, but another functions, this won't work. There are some, like that. I guess there is a reason in the packet implementation why this doesn't work. You can just use import. It won't compile it. There will be very scary errors and a lot of set issues on the about asking why it's happening. But it's still possible to do this. And what actually works? What actually works is that if you have one package called container read-only, where you have this data type map plus key and all the query functions, and all your modification operations should be put in the different package container sig, and you here write all your modification functions, but you also duplicate this part with data type and class. So this is a part we call boilerplate that you need to duplicate definitions. But the types are not different. When you will use when you depend on both packages, container sig read-only and container sig, the signatures will be merged. So here is where signature merging algorithms strikes in. If you have the functions with the same name and same type, or data types with same structure, they will be combined. So if you have two signatures with these maps, if they will be joined, you will have only one single map limitation. So they are not inputted. You are not using it like ordinary model, they actually rely on the signature merging algorithm. So because it works. And those packages even don't need to depend on each other. You don't need to depend on container sig, you don't need in the container sig. They can just be used independently. It's not if you don't have query operations on the computation operations. Why not? So, which means that signatures are actually externally extensible. So, if you are not satisfied with the signature interface of the after these packages, and you don't actually want to open pull request in Python's interface, you can just write your own signature with only a couple of the new functions, and write your two functions you don't find in this interface, and write your functions polymorphic over your interface. You can still enjoy the rest of the ecosystem. If you use the other packages, signatures will be merged. So it means you can add a couple functions, and then they will merge and combine into a single signature that implements it. So if you use that class-based solution and you want to update that class, you either open pull requests to the library and ask them politely to update that class, or you introduce your class with superclass as a constraint, and it's not really easy, but Webpack allows to do this. So as I mentioned, Webpack is not really popular, but there are still libraries which implement something with Webpack. one of the most motivating examples for backpack is the string signatures. So we have string data type and text data type and byte string, and sometimes you want to write functions that work for every data type. And how it's done now is that you write a library with 1,000 lines with like text data type. Then you copy paste it and replace text with byte string, and you publish another library. At least backpack you can write only once. And backpack STL package implements the signature for all string type data types and also contains the signature itself. But it's not on package yet. So okay, another example is unpacked containers package. It's implemented by Edward Met, and this package basically was a copy paste of map from containers package ordered map. But instead of polymorphic key, it uses key as a signature. So it's not polymorphic variable, it's a key which allows to have bug fields and other stuff, and in some cases increases performance like 50%. So it's really useful. Okay. So this is a package that implements signature for containers. If you want to see how the code, the full code, you can call this package and see its contains a lot of packages. You might see that if you work with backpack, it requires you to write a lot of packages. So one package for read-only signature, one package for not read-only signature, one package for ordered map, one package for strict ordered map, one package for strict hash map, one package for strict int map, another 3 packages for lazy versions, and then some contributor packages. So there are a lot of packages needed to write. But there is open pull request in Cabal that supports multiple public libraries. So it can be written even without, after this pull request immersion, this issue appear in Cabal, you can write even shorter with a small amount of packages, so it will be more convenient. So this is a toy example, backpack regex example. If you want to learn something about backpack, you can see different ways of the implement. So there are implementation of regex and string signatures in very small and simple in multiple packages, in single package, and other ways how to implement. It's very useful learning purposes. Now, big example, one of the big examples is the implementation of the reflex specialized to spiders. Reflex that uses very huge signature file. It's more real life example. Another huge example is this Haskell SG library. It implements Haskell bindings for PyTorch. PyTorch is a machine learning library for tensor and neural networks. So there are bindings implemented as signatures, and I guess there is reason for that. Now the reason why backpack is not really popular is because there is not many tutorials for that. But if you want to read something about backpack, so there is an original backpack database of the system implementation. There is a proposal which does how to implement the system for Haskell, how it works. There are 2 tutorials by Edward Young, how to, they're very useful and a possible post with explanation of signatures. That's all. Do you have any questions?
The signature files, is it still legal Haskell or is it a DSL?
It's still legal Haskell. So compiler recognizes, but the only difference is that it starts with signature keyword instead of module.
Okay.
But it's not that it's exactly it's just use a lot of modules that parse it back. Yes.
What about compilation? Is all compilation sort of deferred until all the signatures are instantiated, or is it possible to? Does it do any kind of?
Well, there is process. The diagram in GRC proposal. If you says how it works. So if you compile the packages that depend only on signatures without implementations, you still have like interface files and other stuff, but without the class new implementations. There will be like different types of packages where you substitute, but you still can compile and you still back check. Basically, you can back check, but occasionally don't check the code. But if after you substitute implementation of the signature, it will actually compile.
Actually, based to follow on that, is it possible to have dynamic linking shared objects?
So you could actually compile fully without
compile everything and
without
choosing
instantiation.
link it for everywhere, right?
It's possible.